Hi guys, over the last couple days, 2 days ago you were working on these basic skills that you see in front of you here, and then yesterday you got an introduction to a logarithm. Um, so I just want to run through those two situations with you here, and then your practice for today will be more skills quiz practice and then a little more logarithm practice. So some of you did really well on um, this basic skills worksheet. Some of you need a little more practice, so I just wanted to run through um, some of these problems and kind of work through the problems with you here. And then as you're practicing again, if you have questions on how to work through any of these, please just stop in my office hours and I'd be happy to talk you through anything. All right, so on this one, we see a quadratic, so we know what's going to happen there. It's going to be a parabola centered at the origin, but we get moved left 5, and this stretches that 1, 3, 5 pattern, 1, 3, 5, 7 pattern. It's vertically stretches by a factor of 2, so it's going to go 2, 6, 10, 14, etc. here. So instead of the parabola being here, we've moved it left 5, and instead of it following 1, 3, 5, 7, double it, 2, 6, 10. So notice 2, and then 6, and then of course we can't go 10, so that gives us enough points to get a pretty accurate graph. On this next one, it's a 45, 45, 90, and so on a 45, 45, 90, the only value you have to remember is the square root of 2. That is, if you're using the shortcut. These two sides, because it comes from a square, are always going to be the same, okay? But radical 2 is the relationship between the hypotenuse and these sides. So if you're going for a bigger side, you're going to multiply by radical 2. If you're going for a smaller side, you're going to divide by radical 2. So the shortcut here is we're given the hypotenuse, C is 7 radical 10. So if we want to find these short sides, all we have to do is take 7 radical 10 and divide it by radical 2, and think about reducing these. And we get 7 radical 5 over the square root of 1. And we don't have to include that in our answer, so I'm just writing 7 radical 5 for both of these. Of course, Pythagorean theorem will also work. And if you have a question on that, and instead of taking the shortcut want to use Pythagorean theorem, stop by my office hours and we'll talk about it. All right, for these, and you'll see the same situation for today's literal equation. We're trying to get x by itself, and notice that it's in two spots. X is here and x is here. So the little mathematical strategy is to factor x out of both of these. If you factor an x out of r times x, you're left with r. And if you factor an x out of p times x, you're left with p. So notice at this point, x is in one spot. So if we divide both sides by r plus p, they cancel, and our final equation, x equals k divided by r plus p. So that's our answer there. On the tables, these are set up for you to either be linear or exponential. Linear means adding the same number every time, which is not the case here. Exponential means repeated multiplication, and can you see that there's a repeated multiplication of 3 here? So y equals, the starting amount is 6, and you're repeatedly multiplying by 3. An exponent means repeated multiplication. Let's just check this. If I put a 2, if I input a 2, I should get 54. So if I input a 2 there, 3 squared 9, 9 times 6 is 54. It worked. Plug in, let's get a little tricky here. Let's plug in a negative 1. 3 to the negative 1 power. That's the reciprocal, negative 1. So that's 1/3. 6 times 1/3 is 2, and it worked. Okay, so that's your way of checking that answer. Inverse. A couple ways to look at it. Some of you like to reflect everything over the line y equals x, which is totally fine. So just find some points here, like this point. If I reflect it over this line, it looks to be 1.5 diagonals to the line y equals x. So I'm going to go 1.5, half, and 1. There's the reflection. Others of you might remember that if you just switch x and y, you're finding the inverse also. So the coordinates at this point are 0, 3. So if I switch x and y, 0, 3, 3, 0, and that's right there. Okay, so I'm just going to pick another point here. This is 5, 1. So if I switch 5, 1, I get 1, 5. And that's actually enough information for me to get the inverse here. And so I'm just going to follow this pattern. It looks like it goes down 5 and over 2, so I'm going to do that again. And here's the inverse right here. Okay. This one is a cubic function. Cubic functions look like that. Okay. And they follow a 1, 7 pattern. So let's just see what's going on here. Here's our parent function. It would do this, and it would follow a 1, 7 pattern. But what's going on here? 4 to the right, 5 down. So I'm going to go 4 to the right, 5 down, and this is going to follow a 1, 7. I can't get 7 down here, but I can here. 1, 2, 3, 4, 5, 6, 7. And so now here's how this graph looks. Okay, so there's your cubic function. Go ahead and check on your, I know it says calculators are not allowed, but that's if this were a quiz. You guys are practicing. So if you want to use your calculators to kind of check and verify your points, you know, I think plugging it in and then using your table would be a nice way to do that. Determine the inverse. So just like up here, this is the graphical inverse. Now we're going to find the algebraic inverse, and we're going to switch x and y. So right now, f of x equals the quantity x minus 6 squared. So if I want to take the inverse of this, I'm going to just switch x and y. There's the inverse right there. I just have to get y by itself. So undo the square with a square root. So I'm going to take the square root of this side, and I'm going to take the square root of this side. It's going to undo the square. Then I'm going to add 6 to both sides. And that's the inverse. If you want to, I would be okay with you writing this. If you want to get a little more official, you could say the inverse of f of x is 6 plus or minus the square root of 6. Either one of those is good, though. All right, last one here, factor. It's a trinomial. So trinomials factor like that. And because of this 6x squared, have a couple different options. It's either going to be 3x and 2x, or it might be 6x and 1x. And because this number here is negative, I need to figure out two numbers to multiply to be negative 35, and then when I multiply this together, that middle term is negative 1. Because that number's small, I'm leaning to it being possibly these two. And I'm thinking 5 and 7 here. So it is guess and check, but as you practice this, you'll get better and better. You could plug in 5 and 7. And let's just try it. If I try 5 here and 7 here, one has to be positive, one has to be negative. So let's see, I'm going to make this one negative and this one positive. And if I test negative 21x plus 10x is negative 11x, I need negative 1x, so that didn't work. So the next thing I'm going to do is switch the 5 and the 7, just to see how that affects things. And so check out what happens now when I switch these two. When I multiply here, I get negative 15x, and when I multiply here, I get 14x. Negative 15x plus 14x is negative 1x. So that worked out. All right, so this is the correct answer. This would not have worked. Okay, so if you started with that one, you'd find after you switch things around, it wouldn't work, and then you'd have to go back to that one. Okay, so that's just a rundown there. If you need more specific help and questions, just again stop in my office hours and we'll talk about it. Here's what you guys are going to be working on today. Very similar to what you did yesterday. Notice I didn't put the calculator limitation on there, so if you want to mess around, notice the absolute value. That's the V looking graph. And here's a quadratic. Okay, so just to give you a couple hints there, a lot of these are very similar. This is a 30, 60, 90, and the values you have to remember on this one, if you're using the shortcuts, are the square root of 3 and 2. Those are your relationships between the sides. Here's a factoring. And look at the bottom of the page. Here's some more logarithm practice. So just want to give you if you need a review, go back to yesterday's video and just review what a logarithm means. I'm going to talk to you about this one. There was one similar to this on the practice yesterday. So remember, the word logarithm means logical number, and it helps us undo an exponent. You're basically finding the exponent here. So what this is saying, what logical number do you have to raise 2 to get a value of 1? And so a lot of you can think about it, maybe get the answer. I like to write things down and write it exponentially. So I'm going to rewrite this as, what number do you have to raise 2 to get an answer of 1? What logical number do you have to raise 2 to get an answer of 1? So as I look at this, I know any number raised to the 0 power other than 0 is 1. So the answer to this one, what logical number do you have to raise 2 to get 1? You have to raise 2 to the 0 power to get an answer of 1. You can check, these are all set up to do without a calculator. Make that your goal, but if you need to test things out with your calculator to understand and learn, that's fine too. All right, guys, good luck today. If you have any questions, just stop by my office.